Okay, so with this question we're trying to show you how to do a simplified tree diagram to solve probability questions. So we've got a box of chocolates containing 5 caramellos, 3 Turkish delights and 2 hazelnut chocolates, and 2 chocolates are going to be selected at random without replacement. So we've got to draw a simplified tree diagram to show the sample space firstly. Okay, because we're choosing 2 chocolates, and they could be either caramello, C, Turkish delight, T, or H for hazelnut. That's what we have for our first selection. So our first selection is either caramello, Turkish delight, or hazelnut. And then on the second one, same thing again, we can have caramello, Turkish delight, hazelnut. And then the same again for each, obviously with this top one, that's where you've selected a caramello first. After that you could select a caramello again, so on and so forth. So we fill in the rest of our tree diagram like that. We're going to show the sample space over here. So the sample space will be caramello, 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 Turkish delight, caramello, hazelnut, then Turkish delight, caramello, so on and so forth. Now with the simplified tree diagram, we want to show all the probabilities on these little branches, I guess you'd call them in a tree diagram, would be the right thing to call them. Otherwise you'd have a tree diagram that would be massive and you wouldn't be able to fit it on. So the first thing we work out is what's the probability of selecting a caramello on the first pick. Well, there's 5 caramellos out of a possible 10 chocolates in total. So 5 out of 10 becomes a half. Then for a Turkish delight on the first pick, well, there's 3 out of 10 chocolates, and the hazelnuts is 2 out of 10, or 1/5 if we simplify that. Okay. After that, let's go and do the selection of getting a caramello, selecting a caramello after we've chosen a caramello. Now this is where that without replacement becomes really important. If we've already selected a caramello, the number of caramellos left in the packet are 4, and the total number of chocolates is 9. So it's a 4 out of 9 chance on the second pick of getting a caramello if you already got a caramello on the first one. For the Turkish delights, well, there's still 9 chocolates in total left in, so we put it out of 9. But the number of Turkish delights wouldn't have changed if you've picked a caramello first, so you've still got 3. So it's a 3 out of 9, or a 1/3 chance. If we simplify that, 3 over 9. Then for the hazelnuts, it's out of 9 as well, and that number hasn't changed either. It's 2 out of 9. Now basically all of these are going to be out of 9. There's 9 chocolates. If you've already picked one, there's 9 chocolates left in. Now the number of caramellos, now after you've picked a Turkish delight on the first one, if we've picked a Turkish delight, there's still 5 caramellos left in. So it's a 5 out of 9. If you've picked a Turkish delight on the first one, there were originally 3, but now you're going to have 2 out of 9. And for the hazelnuts, well, there's still 2 left in there because you've picked a Turkish delight on the first one. Then the last step, you've gone, okay, hazelnut, there are still 5 caramellos left. There are still 3 Turkish delight left, giving a third there. And if you picked the hazelnut here already, there are only 2 in the pack to start with. There's only going to be 1 left in for the last one. So that's our tree diagram with the sample space here, all the possible outcomes. And now we want to answer our questions with probabilities. So let's have a look at this one here. Calculate the probability that both of the chocolates are Turkish delight. So we want P, Turkish delight, the probability of getting Turkish delight then a Turkish delight. Well, there's only one way that can happen in the terms of the sample space. But what you end up doing here is you multiply those probabilities there. So we end up going 3 out of 10 multiplied by 2 out of 9. Now, a lot of people reach for the calculator there. You really shouldn't need to reach for the calculator here. You should be able to simplify this fraction, or this, So we have a look and we say, okay, 3 and 9, remember you can simplify diagonally like this. 3 goes into 3 once, 3 goes into 9 3 times, and 2 goes into both 2 and 10. 2 goes into 2 once, 2 goes into 10 5 times. And then it's these simpler numbers that we can multiply. 1 times 1 is 1, and 5 times 3 on the bottom is 15. So it's a 1 in 15 chance. If you did this picking of 2 chocolates 15 times, one of those times you're going to get both of them Turkish Delight. Let's have a look at the next one. It says calculate the probability that at least one of the chocolates is a hazelnut. So I'm going to write a little bit of shorthand here. We want greater than or equal to 1 hazelnut is the way I'm going to just basically summarise what the question's asking here. Now let's have a look at all the possible ways that you could get at least 1 hazelnut. So hazelnut, that's at least 1, that's 2, so that's counted. Hazelnut and Turkish Delight is 1. Hazelnut and Caramello is 1. Turkish Delight and hazelnut, and the last one is up here, the Caramello first, then hazelnut. So the probability of that happening is hazelnut multiplied by getting hazelnut. Now let's just have a look at the probability of that one. Hold on, we'll use the simplified fraction here. It's 1/5 multiplied by 1/9. So the probability of hazelnut is 1/5 multiplied by 1/9. So there's a 1 in 45 chance that both of them will be hazelnut. Let's have a look at the hazelnut Turkish Delight probability. That's 1/5 as well, multiplied by the probability of the next one being a Turkish Delight, which is 1/3, which is a 1 in 15 chance that you're going to get hazelnut then a Turkish Delight. Now, I'm actually going to jump up to this one here. This one was hazelnut Turkish Delight. I'm going to look at Turkish Delight hazelnut. That should be the same probability. If we have a look, it's 3/10. 3/10 for this one up here, multiplied by 2/9. So let's have a look what happens with that one. Well, cancel out that's 3, so 3 goes into both, and 5 and 1. It's a 1 in 15 chance. So the hazelnut Turkish Delight and Turkish Delight hazelnut have the same probability. So that should also work for the hazelnut Caramello, and Caramello hazelnut should have the same probability too. So let's have a look at the probability of hazelnut Caramello. That's 1/5 multiplied by 5/9. 1/5 multiplied by 5/9. Well, let's have a look. 5 and 5 can cancel for 1 and 1. So it's a 1/9 chance. 1 times 1 is 1. 1 times 9 is 9. So it's 1/9 chance. Same thing up here for Caramello and hazelnut. It's a half for Caramello first, and then 2/9 for hazelnut second. So a half multiplied by 2/9. Same thing, cancel there, gives 1/9. So I'm completing this. I'm going to say it's the probability of hazelnut plus the probability of hazelnut Turkish Delight times 2, because there's 2 ways basically that could happen. You could go Turkish Delight hazelnut as well, which is the same probability, plus the probability of hazelnut Caramello times by 2 as well, because there's 2 lots of 1/9 is that probability. So let's go through and finish it off. It's 1/45 for hazelnut plus 1/15 for hazelnut Turkish Delight, but times by 2, plus 1/9 we said, remember, for that probability, times by 2, which is 1/45, plus this here, becomes 2 over 15, plus over here we become 2 over 9. Now again, you could have put this in the calculator back at this step and got the correct answer. I'm going to try and show you how to do this without reaching for a calculator, which you should be able to do. This time we're adding fractions. Before, when we were multiplying fractions, we just simplified and then we multiplied the numerators, multiplied the denominators and got our answer. But when you're adding or subtracting fractions, what you've got to look for is a common denominator. So the lowest common denominator here is 45. Looking here, we've got 45 on this one. It's already got a denominator of 45. But 15, to get it to be 45, we've got to multiply it by 3. So 15 times 3 gives 45. Whatever you do to the bottom of a fraction, though, you've also got to do to the top. So we're also going to multiply that one by 3. Now, this one's got a denominator of 9. To get it to have a denominator of 45, we need to multiply it by 5. 9 times 5 gives 45. And then whatever you do to the bottom, you've got to do to the top as well. So let's just rewrite all of these now with a denominator of 45. 1 over 45 plus this one will become 6 over 45 plus the last one, 2 times 5 will be 10 over 45. And now that we've got a common denominator of 45 for each of them, we simply add the numerators. 1 plus 6 plus 10 is 17 out of 45. Now, with a calculator, you'd be able to change that to a decimal, or as a percentage is also a way of doing it, which is 37.7 recurring percent. Meaning that if you had 45 goes at it 17 times, you'd get at least one hazelnut, or roughly 37.7% of the time out of 100 goes. So 37 or 38 times out of 100, you're going to get that as the outcome.